I just want to acknowledge our West-WRF modeling team here at CW3E. Listed there are several of them on this call, and then elsewhere as well. I see you, Boulder, and then Andy Martin at Portland State. So going through the CW3E of forecasted tools, this is I'll be talking about the high resolution West-WRF forecast. Yeah, so I wanted to review what we did last year for our West-WRF near real time simulations. We ran these 0Z UTC everyday initializations December through March. We actually ran later than that in kind of a non-official capacity, but that's what we define as our operational season. We ran 3 different sets of simulations. One deterministic simulation using GFS. This simulation configuration was all frozen from the year before for machine learning purposes, and then we also ran in ECMWF based deterministic simulation updated a bit from the previous season up to 100 vertical levels. And then we also did a 48 member ensemble with our 9-kilometer domain only. So you can see our model domains on the right there and how they compare to several operational models. The 9-kilometer domains over much of the Eastern and Pacific and Western US and Canada. And then our 3-kilometer domain was mainly over California and then offshore areas. For the 9-kilometer domain, we go out 7 days on that, 5 days for the 3-kilometer. Everything's run on the Comet, from the Comet supercomputer to San Diego Supercomputing Center, which CW3 obtained control over earlier this year. So we're going to have greatly expanded NRT system, which I'll explain a little bit later here. Then we also run these on the ERDIC Onyx system as well. Full-time backups there. This slide here highlights our ensemble, how it was constructed last year. So we had 48 members, split between GEFS and ECMWF. We were on a multi-physics and stochastic kinetic energy backscatter to help increase the spread within the ensemble. You can see on the right there the construction of this split between the members of GEFS and ECMWF, the multi-physics SCAB, and then we run 40 ensemble members out to 5 days operationally, which means we aim to have them ready by about 7 a.m. local time. Off that operational window, we had additional eight members in there. And then we increase all the lead times out to 7 days after the operations as well. So when it's all said and done, every day 0Z UTC initializations, we have 48 members out to 7 days. Yeah, I just want to highlight a couple other research-related non-operational simulations we're involved with right now, which is helping to increase our modeling capacity in the group. The first is the West-WRF 40-year reanalysis. This is supported by the CEC High Resolution Historical Climate Project, led by Dan Kahan here at Scripps, where we're dynamically downscaling the Era 5 reanalysis model level output from Era 5 for the entire 1981 to 2020 period. This is using 100 vertical levels with hourly output. You can see the model domains on the right there are 6 kilometers, through most of North America and then Eastern Pacific, and then 2-kilometer domain over much of the Western U.S. We're still running a sensitivity of simulations on these for a variety of cases, and we hope to start production on this within the next 1 to 2 months or so. Then another project to quickly highlight here. We're involved in a project with SDG&E and others at Scripps, where we're running West-WRF simulations over the greater San Diego area, looking at key pieces of a San Diego coastal flooding. So these are actually going down to 1 kilometer and 333 meter simulations over a San Diego County, using ERA 5 as input, and then the West-WRF output is used to feed coastal wave modeling efforts with Scripps. But this will increase our modeling capacity for sub 1 kilometer simulations, which had a new set of complexity compared to coarser simulations we do at just a few kilometers. So this slide here just highlights our upcoming efforts at this season's NRT simulations. For the deterministic simulations, we're expanding the 3-kilometer domain, cover the whole U.S. West Coast, on Nevada, Idaho, and also offshore areas there as well. Increasing the vertical resolution, the lower troposphere. Matthew Simpson in our group has been involved in putting together a refined vertical level distribution where we hope to greatly improve the simulation of processes in the lower troposphere. Looking to go out to 10 days lead time for the 9-kilometer domain. Have hourly full model output, and then 15-minute of precipitation. That one should be in the next line there. A 15-minute precipitation in near surface output. And then for the NRT ensemble, we're looking at greatly expanding the number of members. We would just run the 9-kilometer domain, but we're looking at something around 200 ensemble members for next year, while also increasing the vertical resolution in the lower troposphere, and the hourly output and 15-minute of precipitation and near surface variables. So that's all I had here for the West-WRF update. Thank you.
All right, thank you, Dan. Are there any questions?
Dan, this is Jay Cordera.
Yeah.
Earlier, there was a question regarding how many members are in the West-WRF reforecast.
Reforecast is not an ensemble.
Oh, it isn't?
That's just
Okay.
one deterministic. Yeah.
I was mistaken. I thought it was an ensemble.
Yeah. No, that would be that'd be nice if we could do that eventually. Yeah.
We have the supercomputer. We should do it.
Yeah. Yeah.
This is Dan also. How are you planning to configure additional ensemble members for this upcoming season's near real-time simulations?
Yeah. For those, we'll use the full set of the ECMWF, which is a 51 members, and then the GEFS, which is up to a 31, I believe now, so 82 members, and then expanding the multi-physics configurations. We last year we did two iterations of the microphysics the PBL and the convectiva schemes will increase that. So increase the multi-physics, and then likely have a few kind of experimental ensemble members that could be swapped in and out as well, where we can also learn a bit more about the model model sensitivity over a full season as well. We weren't really able to do that last year. We just through the kitchen sink kind of at each ensemble member to increase the spread as best we could. I think this year we just want to have enough input conditions to do that, where we'll actually be able to see the model sensitivity a little bit more and how each member contributes to the spread.
Okay, thank you. Are there any other questions? Let's see, someone has their hand raised. Duncan?
Yeah, just a quick question. What model-specific adaptations are present in West-WRF to better handle orographic effects?
Yeah, that's been an active area of research within the group for a while, and then it's increased this year as well, where we're looking at specific model adaptations to the mainly to the microphysics scheme. We've been working with Greg Thompson on his microphysics scheme, where we've been using something Dave Reynolds has been heavily involved in as well. A lot of knowledge of the local meteorology and microphysics, specifically changing several parameters and processes within the microphysics of code to better represent precipitation over most of the coastal ranges and the Sierra Nevada. Then also we're working with the University of Arizona to improve the snow initialization for a model. So this is a snowpack that's used to initialize each model simulation. Usually we just read in the global product, where we can use the daily near real-time University of Arizona snow height and a snow water equivalent product, which is at 4 kilometer resolution, I believe, greatly improving the initial snow condition over the Western US.